Okay, so as we're talking about simplifying radicals, we're going to have to start getting into the talk about variables. Now, since this is a part of algebra, we've seen variables many times before. When you're dealing with simplifying radicals that contain variables in it, what I'm going to do here is I'm just going to make this really big radical sign, and I'm going to expand these. Now, this method works great when the exponents are a relatively small number, but they don't work very well, or this method doesn't work very well, when the numbers are huge. But for this example, we can do it. I have x to the power of 8. So what I'm going to do is I'm going to expand that. So that's just x times 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 x. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to do the same thing with the y's as well. Y, and then z. Now z doesn't have an exponent that you can see, but it's technically 1. So if you would like to write that in there, you can. And I have 1z. Now the way you do this is you basically try to pair up these variables in groups of 2. So there's 1, 2, 3, 4 groups. So there's 4 groups. And you're going to do the same thing with the y's. There is 1 group and 1 left over. And in here there's no groups, but you have no groups and 1 left over. Okay, so in order to simplify this, what this would become would be you have 4 groups of x, so x to the power of 4. You have 1 group of y, so y, and you can put to the power of 1 if you would like to see that right now. But if you look at your leftover, you have a leftover y and a leftover z. Since you couldn't pair them up, they're going to remain inside the radical. That's where your leftovers will be inside of the radical. It's almost like you can think about everybody has to partner up, and this y and this z don't have a dance partner, so they're going to be off to the side by themselves. And that's basically the answer. I actually prefer it without the exponent of 1, because that's more like what you're going to see. But they are both correct. I just consider that the better answer. So you can do the same thing here. If you go here and you look, you can pair this up as A, and 2 B's. And it just so happens that we have 2 groups of A, so A squared, and 1 group of B. Now there's nothing left over. Every single variable has paired up with another variable of the same kind. So there's no leftovers. So we do not need a radical sign. So we can do the same thing here. Now there's a pattern here. There's a quick way to do this. I'm not going to say it until we get to example 3, but there's a quick way to see it. I'm not sure if you know what's going on yet, but hopefully you will after this example. So you have 10 m's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And just for argument here, I'm just going to go underneath it with the n's because I'm running out of space, and with the p's. 8, 9, 10, 11, 12. Alright, so we have 1, 2, 10 m's, 6 n's, and 12 p's. You can do the same thing. I'll make this a little longer. Okay, you can do the same thing. We're going to pair up 1, 2, 3, 4, 5. So this is really m to the 5th. 1, 2, 3 groups of n, so n to the 3rd. And then 1, 2, 3, 4, 5, 6. 6 groups of p. No leftovers, so we actually don't need the radical sign anymore, and that is going to be our final answer. So the pattern here, and now this is where I talked about this is not going to be a useful strategy when you have exponents that are relatively large. And I made these exponents absurdly large so as to discourage you from attempting to do this. Now, if you were really stuck, you really could do this on your own, but I hope you wouldn't, because this would be a massive waste of time. The pattern here is if you have an even exponent, what you can really do is you can just divide the exponents by 2, since you know that you're pairing them up into groups of 2. So this will be x to the 40th, y to the 50th, z to the power of 120, and that's the answer. There wouldn't be any leftovers because they're all even. If it was odd, that'd be a different story. But let's get to odds. So here we are, odds. The same idea. Now, in this one, this has an exponent of 1, and it cannot pair up with anything else. Matter of fact, it's already in the radical by itself, so this is already simplified. You can't do anything with this one. Now, that might seem like a cheap shot, but this is the best that it could be, and you kind of need to know that anyway. However, on any other odd exponent, such as 7, in this case, you can do the same thing. You can probably see what's going to happen. But for odd exponents, because you're looking to group them into pairs, whenever you have an odd exponent, there's always going to be one left over. So this will be b to the power of 3 radical b. And I know that might look weird because you have a b over here, you have a b over here, but that's just what happens. So looking at the next one where you have multiple variables here, now you could probably see the shortcut already, and that's fine if you do, but I'm going to expand this. I have one pair of D, 2 pairs of E, and I have a leftover. I have a leftover D, a leftover E, and a leftover F. But right now I have one pair of D, so D to the power of 1, 2 pairs of E, E squared, and my leftovers will be the D, E, F that could not pair up with any other variable. Down here I've mixed up even and odd exponents. Give these a shot. Matter of fact, I'm just going to put these answers down, but you can expand the exponents for all of them, but at this point in the video, just pause it, try it on your own, and then hit resume. But I'm going to put the answers down, and then if it doesn't work out and if you don't get it right, just expand it out on another piece of paper and see if you get it right. But the answers will be, so you're going to pause it right now, be j squared k to the 4th with a leftover k inside your radical. This one will be a with a leftover a inside the radical, b to the 5th with a leftover b inside the radical, c with no leftover c's on the inside, d to the 3rd with no leftover d's on the inside, and an e on the inside. And then number 3 will be h to the power of 6 on the outside. No leftover h's. There's a leftover g on the inside. And then k to the power of 13 with a leftover k on the inside. Alright, so give it a shot. Hopefully that worked out for you. If you're still stuck, just run it through again. There'll be plenty of times to practice, or just email me. Whoops.